So this is probably the last video in the series. I'm going to begin by explaining what the solution is to the N55 rod bearing failure problem. And then I'm going to explain what are the causes of rod bearing failure on the N55. So there are 9 items in the solution to rod bearing failure on the N55. I'm going to start with the cheapest and easiest and go on to the more complicated and expensive. The first thing you should do is you should immediately unplug your oil pressure control solenoid. You can pause the video and go and do this right now. The oil pressure control solenoid is in the front of the engine. You need to remove the cooling fan in order to get to it. With the oil pressure control solenoid gone, your oil pressure will run at maximum pressure all of the time, which is just what you want for an older N55 engine. Step number 2 is to completely remove the oil pressure control solenoid. And then what you do is you block it off with a blind plug, and here is the part number. This is pretty easy and inexpensive to do. The third thing about these cars is you must never ever actually tip your car forward. So if you've got an X5 and you're doing some off-roading, a very steep hill, going up the hill is no problem, but if going down the hill, all the oil actually tips to the front of the engine and will actually cause your oil pickup tube to suck air. And this will destroy your engine very quickly. So you've got to avoid doing this, and if you absolutely have to go down a steep hill, you maybe, I don't know what the solution is, but you should at least make sure you've got a couple of extra quarts of oil in there, so you actually overfill your engine a little bit for a short time. And perhaps that's one solution. I actually don't know what to do. I've got plans that if I ever have to go down a very steep incline, that I should do it in reverse. So I don't even know what the solution is to this. A deeper oil pan is not available for this BMW, and it's a very, very difficult project to make an oil pan that's deeper. But you basically cannot off-road with this car, even go down a steep driveway, because you could risk sucking air up the oil pickup tube. Item number 4 is to make sure that your oil is full all of the time. So if you go into your vehicle status and you check your oil level, it should always be full. It should never be halfway or quarter of the way down. If it even goes down a quarter, then you need to add a half a quart of oil to bring it up to full level. And if your engine is leaking oil, you need to fix that so that the oil doesn't leak out. Again, your oil pickup tube can suck air when the oil is low. Number 5 is to follow correct oil priming procedures when you work on the car. So if there's any air inside the oil system, you need to fill it up with oil before you start your engine properly. And I actually believe that the oil priming procedure given by BMW doesn't work, because I don't think when the engine is cranking that the oil pump spins fast enough to actually prime the engine. Another procedure is actually to remove the oil pressure sensor and actually use a syringe to squirt in oil. And if you squirt in a couple of quarts of oil through that hole, that should be sufficient to prime your oil and to actually make sure oil gets all the way around the engine to the bearings. And while you're doing this, you can actually turn over your engine manually with a wrench halfway to make sure that the oil holes in the crank actually line up with the rods, and that you can actually get every single rod fully primed with oil. If you're building an engine, you can actually use the oil priming procedure in my video. We actually flip the engine upside down and actually fill everything with oil. Now, some people say you should run thicker oil, 10W40, but you can actually run 10W50 oil. There's nothing wrong with running 10W50 oil, and I think the only disadvantage is that there's a very slight increase in fuel consumption, but it probably isn't even noticeable. You should also make sure you change your oil very often. Remember that engines in the 1990s had service intervals of 3,000 miles. So one thing to do is to actually have a counter which you can buy on Amazon for a couple of bucks. And every time you put in a tank of gas, you can actually click this counter. And when the counter gets to 10, then you change your oil. And that is what I do. basically means that I change my oil every 4,000 miles, which is a reasonable interval for changing oil for any vehicle out there. Now the next solution is to use 230-degree groove main bearings. So I got these bearings especially, they're not that easy to find, and I installed them in the engine. They will ensure that there's more degrees of rotation where the whole of the crank is actually lined up with a groove and actually can receive oil to the rod bearings. Now, there is a disadvantage to this, and that is that your main bearings actually don't get as much support because of the groove. But main bearings are almost never a problem on these BMWs, so that shouldn't be a problem. And these specially grooved main bearings have been sold by a lot of manufacturers for a long time, so it ought not to be a problem. Now Calico will actually coat your rod bearings if you send rod bearings to them. So here I've got coated and uncoated rod bearings. These came back from Calico. You've got to create yourself an order form and get in touch with them and mail them off, and they will charge your card and send them back to you, and they seem to be quite efficient. I don't think they're very interested in dealing with retail customers, so if you're going to deal with them, make sure that you don't mess them around and you have all the information and payment details available to them so that they can process your order efficiently. So finally, the thing that you can do with the oil pump is to use the S55 oil pump, which has the higher flow rate, as I explained. Or you can take an N55 oil pump and you can bore it out like I showed in the video. And that will ensure that you've got a little bit extra oil flow in addition to the fact that your oil is operating at maximum pressure all the time because your solenoid is missing. Now there are some other solutions that people have proposed. The most common one I read on the forums is that you swap your oil pressure sensor and your oil temperature sensor. And what this means is that the DME engine computer is reading the oil pressure from the fuel rail, which is further downstream and where the oil pressure is actually lower. So it thinks that it needs to pump more oil than it would normally. So this increases your oil pressure slightly. So some people have reported that this is a good idea. I'm just listing it here as a suggestion. I haven't tried it. Another idea I had, which no one has proposed, is to install an oil pressure sensor, or install your oil pressure sensor to read oil from the oil rail of the exhaust hydraulic lifters right at the back of the engine. So this is where the cylinder head is against the firewall. There's actually a bung in there to block up the main rail for the exhaust hydraulic lifters. And this is an interesting point to measure oil pressure because it's the very, very furthest point in the whole engine from the oil pump. And the oil pressure should be lowest there than anywhere else in the engine. So if you were to get a copper line, if you were to drill out that bung and get a copper line, you could mount your oil pressure sensor to read pressure from that point in the engine. And this is a very interesting way to trick your DME to thinking that oil pressure is lower than it really is. But it's got another effect, and that is that the DME will make sure the oil pressure is high all the way to your last cam bearing on your exhaust cam. And that'll make sure that your cams never get starvation of oil. Now, this is a very interesting point because you notice on almost all N55s that the cam bearings have horrible wear in them as a result of oil starvation, it seems. So this is universal on all N55s and N52s, and I think it's because there just isn't enough oil pressure on the furthest cam bearings from the oil pump. And this actually will solve that problem, I think. But again, I haven't tried it. This is just an idea, and it's an interesting idea that no one seems to have thought of. Now the MSD tuning software is a way to remap your oil pressure according to some. I haven't tried this. I have no idea if it works, but apparently you can actually get MSD to tell the DME to make oil pressure higher all of the time. And this is equivalent to disconnecting your oil pressure solenoid. And it has other advantages because you can give it the oil pressure that you think that your engine will need without going all out and making it maximum all the time. I haven't tried it, but it's an idea. And finally, I had the idea of using an N52 oil pump, which I showed in another video. And the N52 oil pump is actually bolt-on compatible, provided you block off your oil pressure solenoid with a blind plug. So now I can go into what are the causes of rod bearing failure on the N55. So I've narrowed down the causes of N55 rod bearing failure to one or more of the following effects. And just as a proviso, I'm not talking about people that race N55s on the track and have their oil pickup tubes sucking air because they've cornered so hard or they're braking so hard. The sucking air under the G-load of a track use is a completely different subject. Regular N55s that are used as daily drivers have rod bearing failures, and that is what this discussion is about. So the first thing to understand is that the DME controls oil pressure, and the way it controls it is in the way of a dynamic system. And dynamic systems which are controlled in a feedback loop have peculiar characteristics as they get more and more complicated. They have hysteresis and they have delay. Now, in this case, the DME is measuring the oil pressure at a different location to where the oil is actually pumped. So there's an intrinsic delay or missynchronization in the nature of the system. Now, it's entirely possible that when the driver does certain strange things with his throttle, with his pedal, that the DME could get confused and not give the right oil pressure at the right time, or not be able to actually give oil pressure fast enough. Now, I can imagine that if you're driving along at idle, and let's say you're doing 50 miles an hour and you're doing 1200 RPM, and your oil pressure is as low as it can be for the driving range that this engine experiences. And then suddenly, let's say the driver puts their throttle pedal flat and instantly demands an enormous amount of load from the engine. What is the DME going to do in this situation? Well, it's going to detect that the driver wants more load, and it's going to advance the oil pressure. So it's going to send the right signals to the oil pressure control solenoid and tell the oil pump to pivot and to increase oil flow. And then it's going to wait to see when the oil pressure sensor has indicated that oil pressure is at the appropriate level. Now, that whole process might take, the time that it may take to execute and to successfully raise oil pressure might not be fast enough. And your valve body is actually opened, and boost has actually gotten into this engine, and your cylinders, your pistons are now pushing down much harder than they were a few turns of the crank before, and your oil pressure hasn't got up to speed fast enough. And this is my theory. And this is a very, very difficult theory to confirm because it requires millions of dollars of equipment to try and do the experiment. I don't think there's anything we're going to confirm, but it's very suspicious to me that all these rod bearing problems began with the oil control solenoid and the system where the DME controlled oil pressure. And I think it's an incredibly dangerous design, because how do you really know that the DME can respond fast enough in every single driving condition? Now, the BMW engineers may have thought to themselves, well, this problem happens rarely enough that warranty logistics can deal with it, and it happens rarely enough in the first 75,000 miles or whatever the warranty period is, that we don't need to worry about it. I don't know. Maybe they're just not telling people, and of course it makes sense. Most manufacturers are not really interested in publicizing internal problems that they discover. So in summary, this is just a dynamical system which cannot respond fast enough to the required changes in oil pressure, and therefore it should be completely disabled. So that covers the first idea I have about why you get rod bearing failure. So the second cause of rod bearing failure comes from another design aspect of these BMW engines. Now, when you are designing an engine and you want to minimize mechanical losses, you want to minimize the oil pressure, because the oil pump incurs a lot of energy to turn and pump the oil. So the old style oil pumps of the 70s, 80s, and 90s, which just pumped oil at maximum amount all the time, actually used a lot of power to keep oil pressure so much higher than it needed to be all of the time. So the design is very simple, but you're actually heating up your oil unnecessarily, and you're actually losing power. And the solution to this is the variable rate oil pumps, which many manufacturers have. And then the further solution to this is to actually have the DME adjust the oil pressure to be absolutely minimum for the particular load that the engine is currently running at. Now, if you're going to minimize your oil pressure in this way, you also got to be very sure that your rod bearing clearances are just right, because if they leak oil too much, then the amount of oil pressure that you're delivering isn't going to be enough that the journals will not touch the bearings. And if journals touch the bearings, then the bearing gets destroyed and you have a rod bearing failure. Now, on the other hand, if you make your journals too tight on your bearings, your leakage is very low, and you're going to need very little oil flow in order to keep your journals from touching your bearings. Very tight bearing clearances like this are great if you want very low oil flow, and then you can do with a very small oil pump. But the problem is that as bearing clearances get very tight, you're losing efficiency in the engine. You get mechanical losses as the oil film gets thinner and thinner and thinner. You're actually requiring an enormous amount of power to turn that journal inside the bearing. So you don't want your bearing clearances to be too tight. On the other hand, you don't want your bearing clearances to be too loose. If they're too loose, then your mechanical losses in the bearing are low, but then your oil pump has to be a lot larger in order to pump enough flow to make sure that the bearing never touches the journal again. So there's a very delicate balancing act between the amount of oil flow that you're going to need and your bearing clearances. So if you're a BMW engine designer, you're going to try and balance these things out, and you're going to use your simulation software to look at many different scenarios, and you're going to try and optimize the engine so that the total engine mechanical losses are as low as possible. And one of the things you may have to do is to make very, very sure that your bearing clearances are within very tight ranges. Now, an indication that this theory of mine is true is the fact that the BMW manual tells maintenance to replace rod bearings with matching bearings according to the clearances specified on the crankshaft. So the crankshaft actually has stamped into it what the different clearances should be for each journal on a journal by journal basis, and expects the person replacing the rod bearings to actually get the correct rod bearing in each case for the specific journal. Now, why else would they have asked this except if clearances were within very, very small ranges of tolerances? Now, there's some aftermarket manufacturers that actually sell bearings, and the bearing is just one size. And the clearances that you're likely to get when you replace with these aftermarket bearings is within a normal range that any rod bearing would be on any other engine. But it's unclear whether the DME is going to be able to know or to pump oil at sufficient volume or rate to deal with a higher clearance, or what's going to happen. And the DME can't possibly know what the clearance is on your rod bearings. So as your rod bearings wear, your oil is leaking out of them faster, and your DME needs to raise oil pressure. And your DME can't possibly know to raise oil pressure under those conditions. And then, of course, the problem is exacerbated by your cam bearings. Your cam bearings can also wear. In fact, there are many different places all over the engine where oil can leak faster than it did when that engine rolled out of the factory floor. And in all those cases, the DME has no idea that oil is leaking out there faster, and it can't change the oil pressure based on that information because it doesn't have that information. Now, what was very interesting is reading a blog post where someone replaced all their rod bearings and that immediately had their engine get destroyed. And this actually makes perfect sense to me because they replaced it with aftermarket bearings, which had a very slightly higher clearance, and now oil was leaking out of the bearings faster than the DME expected, and now it couldn't maintain oil pressure. So, some advice might be never to change your rod bearings unless you're going to match them exactly the way BMW has specified. I don't actually know, but it's a theory. And it's impossible to know if every single place where oil leaks within the engine is according to factory spec, is up to factory spec. So the bottom line is that it's impossible to know whether your engine is getting enough oil flow, oil pressure, and the only solution to this is just to raise the oil pressure. And you do that by disabling the oil pressure control solenoid. So the other cause of rod bearing failure I'm going to mention, because this has constantly been discussed on the forums. BMW had very, very long service intervals specified between oil changes. And apparently this causes a lot of problems. I have no idea really what the consequences are of not changing your oil for that long, and why they specify the oil interval changes so long. But it definitely isn't good to have oil which is so old for many different reasons. And it's not really worth discussing because there's so much on the internet about what the effects are of old oil. The one thing I will say is that there is an oil bypass spring which sits in the center of the oil filter inside the oil filter housing, and that bypass spring will open when the oil filter gets clogged. And if that happens, then you get unfiltered oil throughout the whole of your engine. And if you've got unfiltered oil through the whole of your engine, this definitely is going to destroy your rods and main bearings, including your camshafts, and the list of problems it's going to create is very long. But one thing you can actually check is you can remove your oil pressure control solenoid And the oil pressure control solenoid has got a very fine mesh around it protecting the actuator. And that will actually trap bits of metal. So if you take the thing out, which is quite easy to do, and you see that there's metal particles all around there, then you can be sure that at some stage in this engine's life, oil has actually bypassed the filter, and that's very, very bad. And that engine is probably toast. So that's something to consider. But this discussion actually isn't about the long oil change intervals. That's a completely separate discussion, and I'm going to leave that at that.